Alright, so this video is version 2 of the Click Bunnings State Spotlight, also known as the Harbor Freight Spotlight. And this design has a better mounting point, so I'm using the original hinge point here and bracket, and then adapting it to a conduit adapter. So this is a 32 to 25mm adapter from Bunnings, and then I've just glued it together there, so it's got a nice tight bond, and that way there's better support between the actual solar panel housing and the adapter here. So the first step here is to disassemble the bracket, just like this. We'll be reusing this later on, so don't lose the nut and bolt. Just cut this wire off here and undo these 4 screws here. It's just a small Phillips screw. So just remember the old mounting point for the antenna, the bendable antenna, was up the top here. When you bend these antennas, they change the SWR of the antenna, so basically the resonant frequency changes as you bend them, and I believe that's something to do with the coax inside here. Not sure why, but it's actually easier to tune the antenna at less than 90 degrees, like 45 degrees for instance. So that's why I've gone with mounting the antenna at 45 and having it fixed into the top here, just like that. So, which means the panel will be mounted that way up instead of that way up when it's mounted against a fence or a pole. So inside this enclosure you've got some nice gear in here. So obviously the solar panel connected to the main board. It's actually got a overcharge protection and over discharge protection, I believe, and temperature protection too. So these red wires here go into the battery, monitor the monitor the protection temperature of the battery, and if it gets too hot it'll cut off the charging, and then also there's a BMS here as part of the battery, so you've got double protection in case anything goes wrong. So this is a lot better than a lot of the other garden lights sold at Bunnings and other places. So usually my first step here is just to remove the circuit board, the PCB, and battery from the enclosure, so that when I drill it I don't hit the PCB and damage it. I'm using a bit of heat here from hot air rework station, but you could use a hairdryer if you wanted to help remove the foam tape, if you want to get it off cleanly. And then the next step will be just to remove these 2 screws from the PCB. Should just come apart like that. Alright, so yeah, that's it there. I'll be removing this wire here later on, and connecting my NRF seed board to this. So I'll show you how to connect that later, but basically the red wire is the positive, which goes to the switch, and then you want to connect your negative wire to the black wire here. So basically black connects to negative on your seed solar, your seed LoRa module, and then the red connects to the positive of your module. So I'll just show you that right now. So here's one of my other boards already completed. So yeah, as you can see, the red wire connects to that far solar pad there, and then the black wire, or in my case grey wire, connects to the black wire of the battery there. So when you switch the switch on this side, it can switch on and off the module. So that's my module there, my Seed Studio NRF board. So as you can see here, I'm just sticking some of this, they call it electrical, what do you call it? Liquid insulation tape, but you can easily use something like silicone or some sort of glue just to seal around the solar panel to the housing, just in case there are any sort of leaks between the outside and the inside. So what I like to do is use this foil foam that I got from some underfloor insulation. You can probably buy some foil tape or some foil foam from AliExpress or something like that, and I like to use this 480 instant adhesive, also from AliExpress. It's quite good, quite strong. Used it for a few years now. Basically just like super glue, and I'll just be gluing down this pad to the base so that it doesn't lift off. Oh. Just to line that up like this. So what I've done is I've cut this pad because it's probably about 3mm thick, and I've cut it in a way that it has a slight border around the edges. So this lip here actually fits into this inside edge here, so you just got to leave a little bit of gap, only a few mil around the edges, for that to sit nice and flush with the housing. So as you can see, the wires are a little bit kinked here, and that's because this lip where the battery sits in is actually quite high, and it touches the top of the solar panel housing. So what I'll do is I'll trim with the side cutters, I don't know, about 5mm off the edge, top edge, just to allow a bit more room, and also to allow for the extra foam that I've put in there. Alright, as you can see, I've snipped the top edge off this, about 5mm, and I've cut that whole piece out the corner there, just so the battery does sit nice and freely in there, and that side bit can sort of bulge out the side, and I can close the cover nice and flat. Yeah. So the next step now is to drill the hole. So this is actually the most trickiest part. So as you can see there, I've marked the pilot hole location. The reason I'm drilling a small hole on the side and a large hole on the side is because it's actually double walled. So there's a slight air gap, probably a 1mm air gap between the inside wall and the outside wall. And so I want to mount, I want to mount this nut obviously on the outside wall, and the base on the outside wall too. So the bigger hole, the bigger hole down here will allow this whole assembly to slide through to the outside wall, and then I'll mount it like that. I'll show you how I do that in a minute. So I'll drill this hole first. Just make sure I keep it nice and straight so it goes all the way through. So that's my pilot hole, and I'm going to drill the large hole now from this side. So I'm pretty much using a 9mm drill bit, and it's the same diameter, same width as that hole there, or as that groove. Just go real slow. I don't want to go all the way through to the outside. Just want to drill that inside wall out. Still a little bit to go. Cool, so I'll zoom right in there so you can see, but basically you can see the two walls, the inside and the outside. Oh, where am I? There. So you have this slight gap in between, and so yeah, that will allow me to fit my connector right through. I'll drill this hole here next. So for this outside hole, I like to use a 6.5mm bit. The connector itself is around 6mm, but I find that 6mm is a little bit too tight, but you can try it if you want. So yeah, I've got the 6.5mm hole there, and what is that, a 9.5 I think it was on the inside. So I should just be able to take this nut off. And just stick that straight through the hole on the inside. So I'll just zoom in there so you can see. But basically that will go will go through there, and as you can see there, it sits nicely inside that hole but sits on the outside wall. So I think there was enough thread just to put a washer on the outside, you don't need to, but a bit of a spring washer doesn't harm anyone. And then chuck the nut on the outside there, and then tighten it up. So I'm using pliers to tighten this up here, but I usually use a socket set just to get a nice fitting on this connector. And when you are tightening it up, just try and get this what do you call it, a FLA connector as flush, as flat as you can with the housing, as you want it to sit flat on the Seeed NRF board when you do go to plug it in. So now that I've done that, there is a hole that where the wire used to go through to the inside. So what I'm going to do is just put a bit of tape over that hole, and then I'll fill that hole with glue, and also I want to seal around the connector if possible. I mean, probably doesn't matter, but I wouldn't mind just sealing it anyway, just to make sure, 100% sure, that there is no moisture or water or humidity getting through that hole, or even through from the side wall to the inside. I just want to make sure it's fully sealed. Alright, so I've nicely glued up that hole, sealed it up, and what I want to do now is add a breather valve. So these are a black M6 breather valve. It equalizes the pressure inside and outside, preventing the buildup of moisture and stuff like that. So I've marked this hole here in the middle, and what I'll do is I'll use a 6mm drill bit to drill through that. Alrighty, there we go. It's nicely mounted in there. And the next step basically is to reinstall the PCB into the enclosure. So what I've done here is I've just added a dab of hot glue to prevent the wires from snapping off, because the last thing you want is someone opening it up to hook up their USB connection to set up a repeater, and then the wires snapping off. So that's just future proofing some manhandling. And just in regards to reinstalling the PCB, don't forget to install the silicon little gasket cover thing here for the switch. Alright, now that I've got the PCB back installed, the next step is to reinstall your temperature probe there. I like to use the original double-sided tape to fix the probe, and then also to fix the battery down so it doesn't wobble around before you shut down the lid. When you do close the lid, it does sandwich nicely. So the battery does hold quite nice and tight there, and I've just fit the battery protection board out the side there, so that it doesn't bulge up and affect the solar panel clearance. Alright, the next step now is to make this adapter. So this is a conduit adapter, like I said earlier, 32 to 25mm adapter. It's great because it allows you to use one of these 32mm Delta conduit mounting saddles from Bunnings. Sits perfectly over there, and you can fix it to like your fence or a pole or whatever you like. All the other options, you can use a piece of 25mm PVC pipe that fits perfectly in there, and you can choose to mount that with some 25mm saddles or whatever you like onto a pole, or you can even use some hose clamps and clamp it to something. So you've got multiple mounting options. So basically the first step here is to open up the light, because basically you want to be using this nice little interface here, which connects to that. This is actually a step better than my previous build, because it's got little notches out of here, which allow you to lock in an angle nice and tight, where my previous build was a little bit sloppy, but still worked okay. But this is a much better option in my opinion. So basically the first thing we're going to do is open up the light. It's quite a nice light actually. It's got a glass lens. Don't know how they make this so cheap. It's a $16.50 light, and if you've got like a Farm Source card, Fonterra card, you can get it for like $15 or something. So it's quite a bargain. Nice little waterproof light there. They do come apart. I don't have a use for them, so if you want one, let me know. Basically it's just an LED light with the LED board stuck in the back there, no resistors or anything like that. So but basically, yeah, so the next step is to get this thing out. So they're actually a little bit difficult to get out, because they've been press fit in there. They do rotate. They've got a nice little rubber seal in between. But what I do is I like to get the heat gun out. You can probably get the hairdryer out and heat it up to a nice hot temperature. So I've got mine set to 100 degrees, and I just sit it in there for, I don't know, 30 seconds to a minute. And what it will do is it'll soften up the plastic just enough for it to warp just a wee little bit and pop out of the hole when you give it a little bit of pressure. Alright, so it should be hot enough now to just pop it out. There we go, easy as that. So I have tried it without heat, and they do actually snap. Like you'll find that you may snap one of these off. But you can try without heat if you like, but that's just my preference. So yeah, the next step now is just to pull this rubber seal off, because it sort of gets in the way. I actually don't have a spare one of these. I've already glued them all up. But basically they do clip straight into the end. Some of them are quite nice and tight. But what I like to do is use like a PVC plastic pipe cement. It sort of, I guess you could say, it chemically reacts with the plastics and sort of almost melts them together and glues them at the same time. I don't know if that's the right terminology. Another option would be super gluing them, but I feel like this is the stronger option. All you got to do now is just fit that back on there with your, your what do you call this, screw fitting, and your M5 nut, wherever that went, and you're good to go. So I just wanted to show you the results I get with these antennas. Get about 1.2, depends where you hold it. It's 1.2, 1.1. But as soon as you go to bend it, look at that, it throws it right out. The SWR is 2.7. Bend it 90, and it's like 3.2. But what I find is if you bend it back, it sort of comes back to where it should be, 1.2. So when you do go to tune it, just be sure, tune it, don't bend it like that, bend it all the way and then back again, just to get the SWR back to where it should be. So what you can do is you can heat up around here just a little bit, just to help open them up, or you can just manhandle it, and they do pop open. So to tune this, well, you should actually tune it with the cover on, but if it's too high, you actually need to extend it with a little bit of solder and a little bit of wire. Extend the tip here. But what I do is I tune it, I put the cover back on, not all the way, just pretty much like loosely, and then I bend it all the way 90 and then bend it back to 45, which is going to be my resting position. And then yeah, just make sure it's right at as low as I can get it, the SWR as low as I can get it. So just a tip when you're tuning these things, that yeah, bend it 90 and then bend it back to where you want to actually fix it permanently. And so what I like to do is I like to just glue in that fitting there to make sure it doesn't bend after I tune it, because it seems like every time you bend this thing, it slightly changes SWR. So you find that, like, you screw that on, you put that on, even if you just rotate the housing on the end here, it will change the SWR. So they're very, I mean, it takes a lot of force to do that, but they're very sensitive. So after you tune it, fix it in place, super glue it, and then seal it up. So I like to use a coax seal, something like this. So this is just like an always sort of sticky tape, doesn't ever dry up, but you can seal it. It's almost like a putty. You can just wrap it around and seal your connectors, and that's what I've done here. So I've glued it in place, so it's at 45 or roughly, coax sealed around it with that sealant tape, and then I've taped over that to protect the coax seal or whatever you call it, from the UV rays, so that it's fully waterproof, watertight, and not going to break down over time. And so what I like to do is I ship it separate like that, but when I get people to install it or install it myself, I get it screwed on, get the angle right like that, and then I put some more coax tape around this joint here, make sure it's nice and watertight, and then I'll put some insulation tape around this joint here, just to stop it from rotating, because you don't want it to be rotating. Say a bird tries to jump on it or something, you don't want it rotating. It's pretty stiff already, but I like to just strengthen it up with a little bit more tape just to stop it from rotating. And yeah, so basically when you got your conduit pipe here, or even when you fix it, to a pole or whatever, The whole idea is that it's mounted up this way, so that your pole is parallel to your antenna. So basically these two are parallel, and then that way you know it's completely vertical, you know. And the good thing about this mounting bracket is that you can adjust it, so you just loosen off the nut and then you can adjust the angle to make it straight if you say your pole is not quite straight, or your conduit gland is not quite, your saddle clamp is not quite lined up. It's great. You can just set the angle here, so it's good. And that's how I keep my antenna tuning pretty much set to the optimal SWR. That's pretty much it. So yeah, that's the repeater done. Screw up the screws and you're good to go. So make sure that when you do switch it on, the antenna is attached, because you can damage the TX of the radio by switching it on without an antenna. So just be wary of that.